See, so today we are going to discuss about a chapter that is known as waves, right? So before directly jumping into this, we should know that what exactly a wave is called. See, wave means you have to see that it is related to some disturbance. Which disturbance? It is a type of periodic disturbance. So the disturbance that is there, but the nature of that disturbance is what? Periodic. You know what is the meaning of periodic? Periodic means what? It should come to its initial position after a fixed interval of time. That means, see, for the term I am talking about, periodic, that means what? Let's suppose the earth is there and earth will revolve around the sun in how many days? 365 days, 6 hours. है कि नहीं? So with that particular time period, the earth will again come back to its initial position after one complete revolution around the sun. So that is the meaning of what? Periodic. So periodic disturbance, combinedly it is known as what? Wave. Now why it is called disturbance? Because let us analysis, or let us suppose a situation that a steel pond is there and a person is there which will throw a stone onto the steel pond. So definitely the stone will reach at this point. So around that particular point some ripples will be generated and it will be spread outside. The ripples will be spreaded in the outside direction or in the outward direction. So what is the meaning of this ripples? That means a wave is generated on the surface of the pond. समझ में आया कि नहीं? तो this is the example of what? The wave. समझ में आया? Now this wave is divided into so many types based on the dependence. On which basis we are dividing that wave, it is very, very essential, right? So first, if we will talk about on the basis of dependence of medium, let's suppose we want to classify the waves on the basis of dependence of medium. That means what? See, I am directly talking about the types. So first, there are two types of wave. First one is mechanical wave, another one is non-mechanical wave. So now what is the difference between mechanical and non-mechanical? See, here I am speaking something and you are able to listen that particular thing. Why? Because there is a medium in between. What I am speaking, you are exactly that one you are listening, right? What I am speaking, that is exactly you are listening. So you are able to listen, or you able to listen what I am talking is only because there is a medium present in between. If there will be an absence of that particular medium, then we cannot listen what I am speaking. Let us assume that we all will go to the space and we will teach, I will teach there. But in the case of space, you will not be able to listen what I am speaking. But in case of atmosphere, or in case of earth, or in case of the air, what I am speaking, you can able to listen because there is a medium in between, right? But in case of space, there is no medium. So the sound wave requires a medium for its propagation, right? At this particular place, as because the air medium is present, you are able to listen. In the case of space, you are not able to listen because there is no medium. So that means what? The sound wave requires a medium for its propagation, right? So the mechanical wave means what? The wave which requires a medium for its propagation, and without a wave, that particular mechanical wave cannot travel. Contrary to this, we have another type that is known as non-mechanical wave. Non-mechanical means what? Non-mechanical is the completely opposite part of mechanical. That means what? See, just like sound wave is the type of wave which will depend on the medium. If medium is present, it will travel. If medium is not present, it will not travel or it will not transmit. But if we will take example of light, light can travel in a medium, light can travel without a medium also. And if we will see, without a medium, light will travel the fastest, right? Whenever we are dealing with some numericals or whatever the theory of relativity or light something, so the speed of light that we take as 3 into 10 to the power 8 meter per second. In case of what? Vacuum. This is the maximum speed of light. At which part? Vacuum. When we will change the medium, let's suppose we will replace the vacuum medium to water, the speed of the light will reduce. Why reduce? Because there is a denser medium present now. है कि नहीं? वैक्यूम से वाटर अब क्या हो गया? डेंसर हो गया. As because it is more denser, the speed of the light will be less. So in case of light wave, see, in case of water also the light will travel. In case of vacuum also the light can travel. That means light is a wave that will independent of medium. If medium is there, no issue, it will travel. And if there is no medium also, it will travel. That means मीडियम का होना या ना होना उस वेव के लिए कोई मतलब ही नहीं बनता. दैट मीन्स लाइट इज ए वेव विच विल ट्रैवल विथ ए मीडियम और विदाउट ए मीडियम ऑल्सो. समझ में आया? नाउ दिस इज द बेसिस, दिस इज द क्लासिफिकेशन ऑफ द वेव ऑन द बेसिस ऑफ व्हाट? डिपेंडेंस ऑफ मीडियम. बट इफ वी विल सी, इफ वी विल अगेन वांट टू क्लासिफाई द वेव ऑन द बेसिस ऑफ direction of propagation. So on the basis of direction of propagation, again we will classify the wave as two types. First one is what? Transverse wave. Second one is what? Longitudinal. So there are two types again, but this classification is on the basis of what? The direction of propagation. First one is transverse wave, another one is longitudinal wave. In case of transverse wave, if we will see the diagram, see this is the raw diagram of a transverse wave where 2 points lie. First this point is known as crest, this one is what? Trough. Now if you will see, there is a particle in every point of the particular line. In this line, infinite number of particles are there, and the particle will displace on the direction from upward to downward. Up and down motion करेगा कौन? Particle. But the particular wave will travel on the x-axis. That means what? The wave is traveling on the x-axis and the particle is traveling on y-axis. That means there is angle creation in between propagation of the wave and displacement of the particle, and that angle is what? 90 degree, and that angle is 90 degree. So if there is an angle creation of 90 degree in between the propagation of the wave and displacement of the particle, then that particular wave is known as what? Transverse wave. And to know this particular wave is transverse wave, or how to know that this particular wave is a transverse wave, how can you know? First we will see that whether there is a crest or trough. If there are multiple crest or multiple trough, then we can know, or from that particular thing we can know that this particular wave is a transverse wave. Now what is the difference between transverse wave and longitudinal wave? There are different points in case of longitudinal wave. First we will discuss these longitudinal wave will travel on the basis of phases. See, there is a phase. This particular region in this particular region, first we will call this as a compression region, and this particular region is known as rarefaction. Why this is known as compression? Because the particles are closely spaced, very closely spaced. That means this particular region represents what? The particle will contract with themselves. But in this particular rarefaction region, the particle will move away from each other. That means a zone will be created where the particles will be away from each other, and in this particular compression zone, the particles will move towards each other. That means a high density region will be created here, and that high density region will be known as what? Compression. And in this particular region, the density will be less, and for that particular density or less density, there will be a creation of what? Or there will be a movement of particles away from each other, and that particular region is known as what? Rarefaction region. And there is a difference of density also. In case of compression region, the density will be more, and in case of rarefaction region, the density will be less. So to denote whether a wave is a longitudinal wave or a transverse wave, first we will see what points are there in that particular wave. If we are able to see that crest and troughs are there, then we can know this particular wave is what? Transverse wave. But if we are able to see that the two regions are there, compression and rarefaction region, then we can signify that that particular wave is